In the world of artificial intelligence, large language models, or LLMs, have become incredibly powerful tools for generating text, answering questions, and even creating content. But one of the biggest challenges is making these models align with the unique preferences of individual users. That's where this research paper comes in, introducing a new framework called LoRe, which stands for Low-Rank Reward Modeling. This approach aims to personalize LLMs more effectively and efficiently than traditional methods. To start, let's break down the core problem. Traditional techniques for aligning LLMs with human feedback, known as reinforcement learning from human feedback or RLHF, often use a single, monolithic reward function. This means they treat user preferences as a one-size-fits-all system, which doesn't work well because people have diverse tastes, values, and priorities. For example, one user might prefer responses that are highly creative and adventurous, while another might want something more conservative and factual. Existing methods try to handle this by categorizing users into groups based on things like demographics, personality traits, or writing styles. But this can be limiting because it ignores the subtle variations within those groups and requires a lot of data to work properly. The authors of this paper, a team from FAIR at Meta, the University of Washington, and Carnegie Mellon University, argue for a more flexible and scalable solution. They introduce LoRe, which personalizes LLMs by modeling reward functions in a low-rank way. Imagine a reward function as a scoring system that evaluates how well a model's response matches a user's preferences. In LoRe, instead of having a separate, full reward function for each user, they represent these functions in a low-dimensional subspace. This means they break down the reward into a set of shared basis functions. Think of these as fundamental building blocks, and then each user's preferences are captured as a weighted combination of those bases. This low-rank approach is clever because it reduces the complexity. You don't need to learn an entirely new reward function from scratch for every user, which would be computationally expensive and data-intensive. Instead, with just a few examples of a user's feedback, known as few-shot adaptation, LoRe can quickly adjust the weights for those basis functions to tailor the model. This makes it ideal for real-world scenarios where users might not provide a ton of data up front. To understand how this fits into the bigger picture, let's quickly cover some preliminaries from the paper. RLHF is a standard method for training LLMs by using human feedback, like ranking different responses to the same prompt. This feedback helps build a reward model that assigns scores to responses based on perceived quality. The paper references the Bradley-Terry model, a classic statistical framework from 1952, which compares items by assigning them scores and calculating the probability that one is preferred over another. In LoRe, they build on this by extending it to handle personalization through their low-rank decomposition. What makes LoRe stand out is its ability to generalize. The authors tested it on multiple preference datasets and found that it outperforms traditional methods, especially when dealing with unseen users, people whose preferences weren't part of the initial training data. For instance, in experiments, LoRe showed improved accuracy in predicting user preferences and better adaptation without falling into the trap of rigid categorization. This means the model can handle a wide range of users more dynamically, avoiding the pitfalls of assuming everyone fits into predefined boxes. The paper highlights how LoRe integrates seamlessly with multi-objective alignment frameworks. In practice, this allows for personalized response generation in applications like chatbots or content creators, where the model can balance global objectives, like being helpful and safe, with individual user tweaks. And because it's based on low-rank modeling, it's computationally efficient, making it suitable for deployment in real-time systems without needing massive retraining. One of the key innovations here is addressing the scarcity of personalized data. Past efforts often required large amounts of user-specific interactions, which isn't always feasible. LoRe flips that by leveraging shared structures across users, so even with minimal data, it can infer preferences effectively. The authors point out that this builds on recent advancements in datasets and benchmarks for pluralistic alignment, where AI systems are designed to cater to diverse groups without oversimplifying human variability. In their validation section, the team demonstrated LoRe's effectiveness through experiments on various datasets. They compared it to baseline methods and found superior generalization, meaning the model not only performs well on known users but also adapts quickly to new ones. This was measured through metrics like accuracy in preference prediction tasks, where LoRe consistently showed improvements. Overall, LoRe represents a shift towards more inclusive and adaptable AI systems. By using low-rank reward modeling, it paves the way for LLMs that can evolve with user needs in a scalable manner, potentially transforming how we interact with AI in everyday life. The paper was authored by Avinandan Bose and colleagues, with correspondence available at avibose@cs.washington.edu, and it's dated April 22, 2025. This work is a step forward in making AI more personalized and user-centric, addressing the limitations of earlier approaches while opening doors for future research and efficient personalization techniques.